Hey guys, welcome to my new video. In this video, I'm going to talk about deep learning. Deep learning is one of the prominent approach to AI. The mathematical model in deep learning are inspired by the structure of our physical biological neuron. In other words, the model's knowledge are embedded into activation and loss function of the hidden layer. To explore that in details, let's dive deeper into the presentation section.
All right, so taking a look at this Venn diagram, I now believe that you have a basic idea on what an AI system is and where exactly machine learning and deep learning lie under the umbrella of AI. So let's just take a look at these two examples here. And through these two examples, I'm trying to show you how the idea evolved from the classical machine learning to the modern deep learning approach to AI. So let's say that we have two databases. One database is containing the database of all the emails that I have. And the second database contains the pictures of dogs and cats. And I'm trying to develop two distinct AI systems. So the first application that I want to develop is to help me in identifying the spam versus non-spam email. And I'm trying to approach this problem with a classical machine learning approach. So here I'll just take my data and I give it to a data engineer, a human of course, and then they will try to extract the feature out of my data and those set of X and Y, and then they pass it to a model, say decision tree, logistic regression, or an SVM machine learning model, and then they'll just develop a model for me that will be able to classify between the spam and non-spam email. Versus the second example, which data is more complex. And of course, one thing that I forgot to tell you is the files that we have here and the data that we have here in the first database of emails, they are structured data, they are text data. Versus the second data that we have here, these are the images of cat versus dogs. In image, audio, video, they are in unstructured data. And it's really hard for human to distinguish the features between two distinct classes. And also, one thing that I have to add here is that the way we see the picture is not how the computer will look at the picture. So the computer will just take a look at the picture pixel by pixel. They're not looking at the picture the way we do. So when these scientists try to solve this problem, they really struggled a lot, but it failed. So that was in the idea came to their mind that what if we let this task of feature extraction to the model itself? So what if we develop the model that they are able to extract the feature by themselves without telling them explicitly? So they tested different methods, they tested different ways, but almost all failed. One of the things that they were insisting on was using a neural network. So actually this idea of neural network is not a new idea. So it exists since 1980, and they were sort of developing a single neural network, a single neuron, an artificial neuron, that they call it perceptron, and they were getting an input X. They were doing some processing because inside that there was a function, and it was passing the X to that function that was producing some Y. So the scientists even tried to use neural network for this task, but then there were few issues that they sort of blocked the progress at that time. Because first, the neural network were not deep, because no one even thought that they could make a neural network that could be deeper than, let's say, 2 or 3 layers. And then we didn't have a lot of data because neural networks were data hungry. And then we didn't have a lot of computation power because at that time the hardware was at very infancy stages. So that was like the beginning of the careers for companies like NVIDIA or AMD, and that there was not really a lot of sophisticated algorithms and also optimized algorithms. So what the idea here is, like the scientist wanted to develop a deeper neural network. So a neural network is actually a network of artificial neurons that they are organized in layers, and the way they are connected to each other is that every neuron in the first layer is connected to every other neuron in the second layer, and this is actually what makes a neuron, neural network very resource intensive, and it's making them to require a lot of computation power and also a lot of data. So the scientists wanted to also explore the NN or neural network for this task as well. So up to the year 2000, they really did not sort of get any satisfactory result because there was a lot of limiting power, as I mentioned earlier. But starting from 2000 to 2010, because the internet got so popular and a lot of data were produced online, and at the same time, the hardware was sort of developing, the hardware industry in general were developing fast. They were coming with powerful CPUs and GPUs, and also at the same time, some TPU, some specific chip that they were designing for some specific tasks, and most importantly, GPUs. And also, scientists were sort of working on more optimized algorithms. So, and at the same time, if you remember, I talked about a project called ImageNet, and that was a work by the Vision Lab of the University of Stanford, and that was led by Fei-Fei Li. These scientists were sort of backing this idea that a neural network would be a solution, a deep neural network would be a solution to the problem of developing a model that could sort of extract the feature by itself without explicitly telling it. So the people behind ImageNet were sort of organizing different contests, and they were asking people to publish their results. And none of the results were actually satisfactory until 2012. So one thing that I forgot to mention is this ImageNet is a large repository of images of all the objects in the world in sort of 20,000 different classes. Means the images in the ImageNet are having plenty of samples of 20,000 different classes of object in the world. So they were sort of, the organizers of the ImageNet were sort of trying to promote this idea that the people or the scientists had to come with the idea of developing neural networks, and they had to sort of use their data open source, so they could come with a solution to prove that a neural network could be a solution to the idea of solving this problem of learning features automatically by the model itself. So until 2012, a researcher called Alex, I've forgotten the complete name of him, but I think he was from the University of Calgary. So he came up with a model called AlexNet, that the result of his model, which was a deep neural network trained on this ImageNet data, was actually outperforming all other solution that was existing at that time. So that was when that the idea really got a proof that we can sort of push in this direction, and then we could sort of solve this problem. And actually, it proved that it could be a solution, because by then we had powerful computers, we had a lot of data, and then we had sort of optimized algorithms like backpropagation, and also we had different loss function that they are the main component of a single neuron, because the way neurons are working here is you pass an input to one neuron, and then this one neuron is sort of processing that input, and then it's going to give its input to the next neuron, and the sort of activation function that you have inside this neuron is deciding whether this neuron is getting activated or not. So one of the common activation function that are used are sigmoid function. They're also relo in related to the proportionate to the type of problem that you are solving. You need to have that specific type of you need to choose. There are plenty of them, so you need to choose it. That proportionate type of activation function as well, because that's when you will get the result that you're expecting from the deep neural networks. Otherwise, you won't. So the word deep in deep neural network, or DNN, is actually telling you that how many layers of neurons you would have in the hidden layer. So one thing that I have to mention here in the neural network, this is called the input layer, this is called the output layer, and this is called the hidden layer. So the word deep actually refers to the more number of neurons in the hidden layer, and the more neurons you have, the more powerful your model would be. But then at the same time, it would be more data hungry, more computational hungry, and you have to take care of those metrics as well. So there are a lot of applications of deep learning nowadays, because when the first successful example came out with the AlexNet and all his teamworks, then the people tried to push into that direction because they had all the necessary tools that they required. The algorithms were there, the hardware were there, the data were there. So then they found out that this was a right method, that it actually solved the problem that the scientists were struggling with that for 20, 30 years. So there are different applications that deep learnings are used today. One of them is being computer vision, natural language processing, it's like application like ChatGPT and all other stuff. The speech recognition, like virtual assistants like Siri or Alexa. The recommendation system, like Netflix, for example, YouTube or Amazon. And deep learning has really proved to be a very fundamental part of this system. And without deep learning, it wasn't really possible to achieve this level of performance from all these applications. So sort of to wrap up what I discussed, I should tell you that deep learning is a subfield of machine learning that uses neural network with many layers to automatically learn feature from the data, and that's the main part, because that was the main part, because that's the part that scientists were really struggling with that. So it became a game changer, of course, and thanks to the combinations of all this driving technology like data, computing power, and also new algorithms. And it is almost, I could tell you that it's almost powering every major AI application that we see nowadays. So I hope in the next video, I'll be able to explain deep learning more in details, and we can dive deeper into the different parts of a deep neural network. We'll be covering the activation function, what kind of functions we can use, and the different sort of functions that we could use inside a neuron. And at the same time, we will be also discussing the different application. Probably once you build a solid foundation of what it is exactly, then we will be going to develop a deep neural network from scratch for, let's say, the same example that I told you here, classification of images of dog versus cat or any other application.
Thanks for watching the video. I hope you've got the basic ideas behind deep learning. If you like my video, please consider subscribing to my YouTube channel. I'm looking forward to see you in the next videos. Until then, take care.